Academy for Astronomy, Space Sciences, and Technology. I would like to welcome everybody who is here now with us in this channel, in this planetarium, virtual planetarium show. This actually can be seen on Fridays 8 p.m. in Arabic بالعربي كل جمعة 8 مساء, and the same time at 8 p.m. On Saturdays on English. Thank you for joining to us, and we would like today, as usual, to take you through a journey through the universe from the UAE to the outer space to see how big the universe is, to be more familiar with the universe. And also we would like to focus on one important concept which is recently actually is studied by the scientists and astronomers, which is the hazardous objects or potentially hazardous objects, and also we will actually allow our team member or astronomer Muhammad Hani to talk a little bit about it, and would like to focus maybe on some objects of those objects, because there are many hazardous objects in the sky, and most of them either asteroids or comets. So we would like to see what a comet is, what also to define what an asteroid is, where they lie in the solar system, and the possibility to hit our planet Earth. This is our sky in Sharjah, and the time is just after the sunset. The light pollution actually prevents us to see more stars because of the light of the cities. The ideal way to see more stars is either to go away from the city, from the light polluted cities, or to come to us, to the planetarium. But now the planetarium, as you know, is still closed because of COVID-19. But we all wish to this situation to be soon recovered, and everybody can go to his or her office and then to visit our planetarium and the space exhibitions. I will show you. This is actually our planetarium. As you see, there are 200 seats and very large dome above you when you visit us, to see in 360 degrees everywhere, to enjoy the sky and to have a very special experience. This is the timetable for the virtual planetarium shows this moment. We hope this to be cancelled and to go directly to the planetarium with you. This is the planetarium again from outside, and inside the planetarium you can actually enjoy tons of space exhibits by which you can learn a lot. You and the children, the students usually benefit them, and everybody can visit this very beautiful and informative and educative place. Let's go back now to see our universe. This is the sky, how it looks from Sharjah. I would like to play with time as usual. This is why the planetariums actually play a big role in education, astronomy education, because you can go forward to see what is going in the future, or to go backward to see what happened in the past, plus today, of course. So now we will see most of that. This is actually the sky, and you can see some stars here. You can see the constellation, one small constellation, which is part of a bigger constellation. This is actually is called the Big Dipper. I will speed up time now to be able to see the sky uh, moving, so we can see the darker sky. Now I have chosen uh, now 1 minute or 2 minutes uh, in here, or here 1 second here equals 2 minutes in the actual outside. Uh, there are actually many constellations in the sky. There are 88 constellations, uh, but actually, how to identify them? We need to connect the stars, not in our way, but in the ancients' way, because the ancients did this beautiful game by connecting the stars. They actually uh, obtained very beautiful figures of the ancients' mythology and the heroes of the myths of the mythology. I will connect some of those stars now. Now I have connected seven of them. This actually is the Big Dipper, as you see. And uh, by connecting these two stars, you will be able to find a very beautiful star. This is actually is called Polaris. Polaris, it is not a bright star. It is only it is music is too high maybe there. Okay, too high. And there is one mic is open. I wish if we can just make sure uh, all mics are off. Uh, okay, let's continue now. Uh, this star is about 430 light years away from us. It is not the brightest one, but it is the most important star when it comes to navigation and finding your place if you got lost in the desert or in the sea. So the ancients actually uh, uh, had to understand how to find out the locations, the directions, and to understand the motion of the sky. Uh, as you see, the sky is orbiting, or it looks as if it's orbiting this star, which is Polaris. All the stars look as if they orbit. I will speed up, and please try to see how all stars orbit or appear to orbit the star because of the motion of the Earth. I will also add uh, one more thing here, which is the local meridian, which is actually a circle that divides the whole sphere into east and west. Here is the east, and here is the west of the sky. As you see now, the sun is appearing from this because morning time, but fortunately, by the way, the pole star is still here at 25 because that's the latitude of Sharjah, but but we cannot see it. Now, fortunately, by this educative software, we can actually uh, uh, just take away the atmosphere and then we be able to see the stars. As you see now, the sun is there, but also the stars are there to tell so the students can understand the motion of everything in the sky. This is daytime, but we removed actually the atmosphere. That's why the atmosphere is the only thing that actually prevents us from seeing the stars. Uh, as you see here, the pole star lies at about 24.5 degrees. That is the latitude of wherever you are. I will now try to take you to a city away from here to see how that would affect the height of the star, which is Polaris, the pole star. Pole star is actually part of a constellation or asterism. Sorry, yes, asterism, small one, which is called the Little Dipper. Here, this is the Big Dipper, and this is the Little Dipper. And both are asterisms, means they are part of a bigger constellation. We will see that later. But I will stop at this moment and I will take you away from Sharjah to go to a city at a higher latitude city. I will try to go to London, for example, to see how that would affect. Remember, this is the Polaris. It lies at about 10, 20, 25 degrees. But what would happen if we go to London? Please try to see with me. Now I'm flying. I don't know, something is always I have problem with flying from here. I'm sorry. Okay, I will leave this point. I tested it was okay, but no problem. So let's fly to the outer space at this moment to see. Before that, I would like to show the constellations. That's a very beautiful thing to see, actually. There are 88 constellations in the sky, and here we see some of them, not all, actually. Uh, these constellations, actually, we see here the way the ancients connected the stars, the bright stars of them, actually, to find these shapes. This is Drago or the dragon. Here is the Little Dipper, the asterism. But here the whole constellation, which is the Ursa Major. And here you see actually the Little Dipper. Here you see actually another constellation, which is the King, Cepheus. Here you see his wife, the Queen, Cassiopeia. And here you see Hercules. Here you see Lyra. Here you see Cygnus. So there are many constellations in the sky. If we go to the left or right, you see actually also more constellations everywhere. Those in yellow color are what we call the zodiac constellations, the 12 famous constellations, which are now 13 by the new or the recent consideration of adding one more constellation, which is Ophiuchus, the 13th constellation, which is this one actually. Here you see Libra, here is Scorpius, here is Sagittarius, and this is Ophiuchus. This is the sky, this is south here, by the way. Now we can move towards the north again before we travel to the outer space together. From this point, I would like to take you to the outer space. We are in the outer space. We still are traveling away from the Earth. This is our Earth with the atmosphere effect, because we can actually remove or enable and disable everything. This is actually more educative to understand how that would affect the picture or the universe, the stars, and everything. This is our home. If we travel away from the Earth, the first to see will be the moon. We will see the moon right now. I will enlarge them, this moon and the Earth, the size I mean. Now we can see both the Earth and the moon. This is actually not to scale. If this is the size of the Earth and this is the size of the moon, the distance is not to scale. And vice versa is acceptable. If I would like to make this to scale, now I will, this actually 10 times bigger and this 10 times bigger. So see how that would be actually if I want to put the Earth and the moon to scale, so they would look like this. Look, this is the size of the Earth versus the size of the moon here. Look, this is the distance. So the moon is, how far the moon is from the Earth? It is about 30 times as much as the diameter of the Earth. This is 30 to 31 times of the diameter of the Earth. So it is very far compared to what we usually see in the pictures, in the internet, when they put the Earth and the moon in one picture. So I will, but sometimes we need this to understand what's going on, how they orbit each other. I will also go to that faked scale. This is the Earth and the moon, not to scale again. I will now allow the moon to orbit the Earth to see how that takes place. I will choose different time interval. This is 10. This is 1 hour. 1 second here is 10 hours in the reality. 1 hour, sorry, in the reality. I will increase that to 2 hours or even more. You can see now the motion of the moon. Look, now I would like to go directly to the moon. Let's go to the moon to see something important about our topic for today. This is our moon. What you see is very important. You see actually the craters on the moon. So the question is, where did these craters come from? So what caused these craters is very important question. And the answer is there with Mr. Muhammad Hani, who will talk about the collisions of the small solar system objects like asteroids and comets. So let's travel away to talk a little bit about the asteroids belt, and asteroids, the belt of asteroids. Now we are at a bigger scale now. What we see now is the orbits of the planets. We see the sun, we see Mercury is here, Venus is here, the Earth and Mars, this is Jupiter, Saturn, this is Uranus and Neptune. Actually, because of the scale, we cannot see the size, we cannot see the whole, they can't see the planets, but to see them, we have to go again back to to a faked scale, we will enlarge these objects about 1,000 times to be able to see them. Now, this is 1,000 times bigger, everyone. So you can see maybe now easier to see the Earth. Mercury even is here. This is Mercury. Push Mercury towards the sunlight, so we have to see it from night. So this is Mercury, this is Venus, this is the Earth. Mars is there just behind the Earth as you see it. This is Jupiter, and that is Uranus. This is Neptune. Saturn is at right now. That is Saturn. But where do the asteroids actually lie in the solar system? So here is where the asteroids between Mars and Jupiter, the majority of the asteroids, which millions actually, lie between Mars and Jupiter. And as you see, some of them are actually interfering or interference between these objects and the Earth and the other planets in the solar system. So some of them are really dangerous. So we have to understand them to avoid any collision. So now Mr. Muhammad Hani is there. Assalamu alaikum.
Yes, assalamu alaikum. How are you,
Alaikum
everyone?
salam. Yeah,
Yes.
Mr. Muhammad Hani, we see millions, as you see here, millions of asteroids between Mars and Jupiter, as you see, and as the audience see here. And of course, there is more here. This is the belt, the main belt of asteroids. There's another belt here. It's called Kuiper. Now, I believe we'll talk about that. But we would like to focus on something happened about 30 or 65 million years ago when the dinosaurs plus about 750,000 species, when they disappeared about 65 million years ago because of some collision happened that time. And also between every month or every 2 years or by time, we hear about a new object is passing close to the Earth. Sometimes some of them we hear that we get some news saying that an object has exploded above one city, caused a lot of troubles. So tell us why we need to study this and what is the story, please?
Yes.
Muhammad.
Assalamu alaikum. The majority of the asteroid coming from outer space, really from the asteroid belt or from the outer space, from the interstellar object. But NASA has defined any object come too close to the.
Please.
Yes.
You mean interstellar means they come from the distance between the stars, means
Yes,
away from the solar system, not from the solar system itself.
Yes, yes.
So some
that's what I mean.
coming there and some
Yes.
are from the solar system. Is that what you mean?
Yes, of course, yes. And NASA define any object, any near object come close to the Earth as NEO, near Earth object. And they are divided into two groups, the asteroid and the comets. I will share now some.
Would you like to share something from you?
Yes, something.
Good
Yes,
news.
please.
Yes,
Yes.
good news. I will now stop my sharing so you can please
Yes,
do that.
please. Okay.
Yes, we can see
Yes,
a very
please.
large crater on
Yes.
Earth. Yeah, please.
Yes, just I will talk within a while. But first, for the NEOs, this is in general. Okay, NEOs, any object, near Earth object, is divided in asteroid or comets. It must reach 1.5 AU. What 1.5 AU? That means astronomical unit. One astronomical unit is the distance between the Earth and the Sun. In kilometers, 150 million kilometers. That means any object reach this point, 1.3 AU, this is an AU, NAO, asteroid and comets. And I show here that what I mean the perihelion. That means the distance, the closest distance between this object and the orbit. But to be danger to the Earth, it must be an PHAS. What? That means an potential hazardous object. And the majority or are their asteroid, not comet. The comet, it's very far, and it has a period of 400 years. And if it is an PHAS, that means a potential hazardous object, it must has three parameters to be dangerous on the Earth. For first of all, the size. It must have an 140 meters or larger than. Second, it must reach 0.05 AU, which in kilometers means that it's 7.5 approximately million kilometers. And third point, it's the absolute magnitude, which we name, the scientists name H, big H. It must have less than or equal 22, absolute magnitude. That means if it has 22 or less than 22, that means the size is between 100 and 150 meters. But it's not necessary that the asteroid classified as PHS will impact the Earth. It's only means that there is a possibility for such a threat. Maybe it become dangerous, maybe it become not dangerous, but it must have these 3 points, which I talk about. Now I will take you. The scientists, they divide the NEA, near Earth object, in groups. The most important one is the ATIRAS, the last one, as you see here. This is, it reach less than 1 AU, and this has become very dangerous for the Earth. And as you see, we have so many examples. It was ATIRAS in April 28, April 22, 2020. The asteroid, we have here so many. The scientists, they discover more than 22,000 asteroid NEA, and between them there is 21 which are ATIRAS, very important, very dangerous for the Earth. And this one is the meteor crater. You know all these pictures. It was the impact with the Earth. It was 50,000 years before, with a meteorite, iron meteorite. The impactor diameter was 50 meter. 50 meter. That means it can make a hole, in the Arizona. But if it can bigger than this size, it can maybe destroy a city. But fortunately, it was 50 meter, and he make an 1,186 kilometers diameter. And the last study say that the speed of the impact, it was 12.8 kilometers per second, and it make this is the last study. And also,
so what you mean, Muhammad Hani,
yes.
is not only the moon is actually subject
Yes, not only Mars, we
such
have the
collision.
craters.
So we even on the Earth,
We can have this.
yes, can have something like this, that hit,
Yes.
which is really very dangerous. So this is a very huge crater. So let's imagine if this happened in a country, it will destroy maybe big area, huge area of the country. Yes, look, this is about 1.5 kilometer in diameter, or 1 mile in diameter. So it is huge, really huge.
Yes. And the scientists, they say the impact energy has been estimated to 10 megaton.
Wow.
10 megaton, that huge in that moment. Fortunately, we wasn't here at that moment. And
10 megaton, but
yes, in megaton, yes.
yes, the
Yes.
the Hiroshima bomb, the nuclear one, it is only 15K ton, 15K.
Yes.
So this
This
one
one
is
is mega
18,
more.
means
Yes.
1,000 times, more than 1,000 times bigger.
Yes.
Wow.
And
Yeah.
imagine if this now can impact now any region on the earth, it will do it make a very huge damage. And this one, this is the 2013 Shylbanisk. This is the hit in Russia, and it has a size approximately 18 meters, and the scientists collected 53 sample from it because it was burned on approximately 23 kilometers above the earth. Fortunately, it was not hitting the earth directly,
Good
but it
omen.
was burned, yes. And it make a big damage also, approximately 7,800 building, and left 1,500 people injured. And
Wow.
he said that the impactor belong the Apollo group. As I tell you before in the president slide, we divide this object to Apollo and Ateras and Amor, and this one was the group of Apollo. That mean which is dangerous for the Earth also. And there was
Okay.
also, as I can see, a lot of in 2019 also in Caribbean Sea. But
So what you mean is Apollo group is a specific
yes,
asteroids. They
this is
named
asteroid, yes, specific.
after Apollo, the historical, not Apollo, the
No,
moon's
no.
journey project.
The scientists divide the
Yes,
NEA, the near Earth asteroid object, in group.
yes,
There is Atira, Aten, and Apollo and Amor. This is,
yes.
some kind of group, some kind of asteroid, which has, I will show you.
So there are thousands, right?
Yes, this one, yes. Yes. This is the Amorous. That mean it's the orbit is not close to the Earth. This is between Mars and the Earth. Fortunately, this is not very close to us. Apollo's os, it become little close to the Earth. It's not very, very far. As you see here, this is more than 1.8 AU.
Yeah, yeah,
And the Athens also Earth crossing, Apollos and Earth crossing. That means it can be on Mars and it can come to the Earth. That's why it's we named Earth crossing.
yeah.
The Athens also
Just
Earth crossing.
maybe just we would like to just to mention that the
Yes,
AU, one AU means the distance between the Earth and the
yes,
Sun, which is estimated to about 150 million kilometers. This is a
yes,
astronomical unit. Yeah.
yes. Uh, okay, I will go for this one. Do you think yesterday, 6th June, there was what mean Earth crossing asteroid. We did not know about that, but I discovered today. This asteroid, 2002
What do you mean by discovered?
NE4.
You discovered it or you read about it?
Yes, today I read
Okay,
about it. That mean
okay.
I read about yesterday about that. That
Yeah.
mean yesterday it happened.
Yeah.
It was discovered in 2002 and was predicted to cross the Earth in 6th June. That means yesterday.
Yeah. Okay.
Yesterday. Okay.
Interesting.
This is very, yeah, very famous one. Uh,
Yeah.
and this is a very small Aten, as I tell you now. You can understand what is Aten class asteroid now.
Yes.
And it was 250. The scientists they said it is between 250 and 570-meter diameter.
Huge enough
Yes,
to
huge. And
destroy a complete country.
yes, and fortunately, it was an 1.00 AU from Earth orbit, and
Mm.
that means 100, 500, 1 million
1 million.
500 million, 1 million, yes, 1 million 500 kilometers. This
Yeah.
means that it was relatively close to Earth orbit, but we did not know about that. But fortunately, the scientists, they are here. They now can classify all this asteroid. They can study. They have a lot of engine as the telescope, the space telescope, to discover this and to tell us that means there is some asteroid very close to the Earth. Pay attention, and in the future, maybe there will be a lot of method. I will take you into this site to see the orbit of the Earth. this,
Yeah.
maybe, yes, here.
If that doesn't take time, no
Yeah,
problem.
no, 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 no. It will not take time, but it's very amazing. You will see. Uh, I will go faster. You see this.
We
You can
cannot.
see
We
now.
have to share it. Maybe.
Yes.
Maybe you have to share it. You still can see the presentation only.
Ah, I have to go to.
Uh, if that takes time, no problem. We can come
No,
back
no.
to share it.
I see. I now I can see this, but I don't know how to. I
Yeah.
think it will go directly, but
No, no, no problem.
okay, okay. Unfortunately, for this one, it was also in 2019, last year, and it
Mm.
was very close to the Earth. Uh, you see, very close to the Earth is 2019. It was classified as PHA also, and you see, you can see now
We can see the
the video,
animation, right?
the
Yes.
animation. Yes, this is the animation. This was the last year. And this became from the Oumuamua, came from the interstellar. It was a very dangerous one. They considered as by the scientists as from maybe from as 2017, and they think this is a big spacecraft. And this is the telescope which can discover all this object, WISE, a wide field infrared survey, which used by the scientists to discover all this asteroid. And they discovered a lot of thousands of asteroids come from the outer with this telescope. And finally, near Earth object, this graph can show us from 1980 to 2020 how we can discover by recently can study all this object discovered by this telescope WISE. And you can see here a different color, red. This is the most dangerous one, orange, and the blue. Uh, Fortunately, we can now, maybe one day we have to discover a method to prevent us from any object coming from the outer space. Thank you.
Shukran. Thank you very much, Mr. Muhammad Hani. And now I would like to take you back to the screen, the space astronomy
Okay.
one. Okay, let me just go to Zoom and start showing screen two, and we are here. Yes. Okay, so this is again back to the solar system. This is the solar system here. And as we mentioned, those dangerous uh, asteroids must be here, intersect the orbit of the Earth. I will point to those ones now. So here, thousands of them, as you see, and most of them, actually, most of those asteroids have been identified in terms of the orbit, the orbital period, and size. Sometimes, and when the first intersecting is taking place, maybe the second, the third, maybe because sometimes it may intersect with the Earth this time safely, but maybe after 2, 3, 5 times, it will not be as safe as it is right now. So we have to calculate onward for the future. So this is why this new field of studying the near-Earth object is very important, because the scientists now they have actually put some scenarios in defending the Earth against such collisions and impacts. So some of them they say, okay, maybe we send the nuclear bombs to rockets to hit them from there, so to scatter them, to destroy them, and or to push them away from the Earth. So there is different scenarios, but this is a very important field of astronomy right now. And now, okay, so let me just take you even further from here to see uh, the solar system again. To see these the all uh, the asteroids belt between Mars and Jupiter. This is Kuiper asteroid belt, another belt where Pluto is. This Pluto is here actually, and all of that actually are still there is Oort cloud. Oort cloud is the cloud where the most of the comets come from. It's about 1 light year across surrounding the sun. So that is the sun and family and the nearby area that actually where the sun is dominating its place in the galaxy. Now at this distance, we have traveled very high, very high distance, or now we are in our way to a point to see the whole galaxy. We see now the stars are moving because of our speed that we are traveling at this time. This is faster than the light, very much faster than the light. Now you see the stars, the constellations now must become different, like the way we know them. We can see the different scales now. This is the scale 10,000 light years across the galaxy now, this one, and this is our galaxy, the Milky Way. Look, this is our galaxy, a very large galaxy, estimated to about 100,000 light years across from here to here. And this galaxy is not the largest one. It's really large. There are many small galaxies are orbiting ours. The Magellan 1 and 2, or the large Magellan Cloud and the small Magellan Cloud. And actually, beside those, there are about 54 or more than 50 galaxies all together are linked physically together to make what we call the local group of galaxies. And our galaxy in this group comes in the second in terms of size. So I'll show you those, most of those, the local group. Those, the ones, the green ones that you can see the faster, which is the closer to mean, that means those are the local group. 2 or 3 are really large in this group, M31, and also the triangulum galaxies. Those are really big, but M31 is even larger than our galaxy, the Milky Way galaxy. Now I move even faster away from our home, then you can see millions of galaxies. And at this scale, you see the galaxies are gathering together to make clusters of galaxies. And this again, the clusters of galaxies gather together to make super clusters of galaxies. We actually belong to something called the Virgo supercluster of galaxies, and so on, before we reach to a point that we call the observable universe. Actually, we don't know how big the universe is, but we still study. We don't know actually. This is the observable universe, where we estimate about there are 2 trillion of galaxies, but this is still small part of the real universe, as we don't know. So we hope to understand more by developing science, developing astronomy and space technologies, and exploring the universe by the different spectrum of light, from the radio to microwave, the red, the infrared, and the visible light, through also the ultraviolet, the X-ray and gamma ray. All of that actually would help us to understand the universe, the whole picture of the universe. Only studying the universe only with visible light is only giving small or one layer among many layers, one layer of understanding of the universe. We have to integrate the picture by studying all types of energy that we receive from the universe. So this is our universe actually. Uh, I will go back to the Earth back because and the Moon because there is something important about the Moon we would like to talk about. Try to see the scale. This is 10. This galaxy is 10,000 light years. This is 10,000. This is 1,000, I think, and so on till we reach our solar system. We still are lost in the universe. That is should be the solar system. Where is our planet Earth? Is here. Look how many asteroids are there. I mean, close to the Earth that are considered to be hazardous asteroids. This is our moon. So there is yesterday we had actually an event related to the moon, which is Pin-Ampero lunar eclipse took place yesterday night time. We would like to simulate this one actually. I will move from this application to another application. This one is called Stellarium. It is an open source program, which is really very good. And I recommend this one to every person who is he or she is interested in astronomy to understand the different constellations, the stars, the events, the day by day events. It is easy to understand and an open source by Stellarium. That's the name of this program. And you can see it actually in different languages, by the way. You can choose your favorite language, including Arabic and all most of the languages. Uh, Here you see the west direction. Obviously, the sun has set from this point. We can go back in time. This is actually the power of such programs. You can play with time. You can go to the future. You can go to the past. We can simulate any time and any place as well. As you see here, we are in Sharjah now here. However, you can go to any other place in the world, in the earth. Not only this, but you can even travel to the moon and see how the sky would look like from there. You can go to Mars, to Jupiter, to anywhere. This is the power of this one. So let's go back in time. Look, I'm just this is now 7:30 today. Okay, uh, today, as you see here, this is the sun set time. You can see the sun here is the sun. You can see it. So you can zoom in, zoom out, of course, easily. And let's travel in time by clicking here. By this, we can actually travel in time or speed up time, actually. This is today's June 6th. You can increase and decrease the speed. It stop here. This is actually is a satellite, I think the ISS there. Here is Mercury, the first to see after the sunset. And these are stars, actually. Uh, we can connect the stars to understand the constellations. This is Leo here. This is the crab, actually Cancer. And this is uh, Gemini. These are the two bright stars, Pollux and Castor. This is Procyon, the bright star of the Canis Minor. And again, this is the North Star. This is the Big Dipper here, and this is the Little Dipper. We look at the west here. You see some objects are moving. Those are nothing but satellites. So this program also, if you update it day after day or day by day, then you can get the satellites motions. This is actually here is this, you can disable it. Also, it can show the meteor showers and showers or the shooting stars or the meteors, actually we call it in astronomy. Where are the planets? We only can see only one planet here, which is Mercury, as you see. However, there is 5 planets can be seen naked eye plus the sun and the moon, of course. Venus was in this area only 2 weeks ago, but now it's close to the sun and it is in its journey to the morning star. So we'll be able to see it in the morning. We try to see that in the morning star, the stars, but the east and not in the west. So let's go to the east to see what is going on here. So this is the east. You can see different constellations. Again, this is Virgo. Here is Libra. This is Ophiuchus. Here is part of Scorpion. I will speed time to see how the moon is rising at this moment. Yesterday, we had a lunar eclipse. We'll see that yesterday. So if we stop here, so let's see even the morning before we simulate that. I will speed up to see. This is the moon. This is Jupiter. So if we'd like to see when Jupiter, actually, I will go back. You can stop now. When Jupiter rises, this is the time. Tonight at about 10:30, the Jupiter will be just above the horizon. Saturn is just after Jupiter. So let's speed up here. This is Saturn, close to Jupiter. There's good opportunity for those who would like to see the planets together, not together in one feed, I mean, but in small in the sky as line up. So this is good opportunity. So this is the east direction. Tonight at 11 o'clock will be high enough to see them. And they're so bright, I mean bright enough to distinguish them from the stars and even the bright stars. One planet, the red planet, should be now very close. Here, I will speed up to see Mars. Where is Mars? This is very fast planet. This is why it moves. This is Mars. So what time it actually, let me go back to see when it rises. Look, now it's rising. So at 1 o'clock, about 1 o'clock, it will be just above the eastern horizon. So by this program, and there are many other programs come in your mobile phone, you can actually download them for free. And this is a free one, actually. You can follow up to see the sky. Let's move on to see the morning sky. As we mentioned, we'd like to see where Venus can be seen in the morning, if it can be seen in the morning time or not. Okay, the morning time Now, still we cannot see anything here. The sun is almost there, but we still cannot see Venus. This means it still needs time to be able to come. It has to come here above the horizon enough distance or away from the sun, separation distance, that we call the, the separation distance between two objects. If we look, Venus is here, so it can be seen by maybe astronomers too close to the sun. This is too close, not easy to be seen by anyone. So need special way to see it, telescopes or binoculars, but we have to be careful about the sun. Before the sun sets, we have to stop. Before the sun rises, sorry. So let's go back to yesterday to see the lunar eclipse. Let's go. I will stop here. Time. This is now. Go to yesterday, 5th of June, and go to the time when the moon was rising from the east. Now, this is the sun here. When the sun sets, the moon, if the moon is full, the moon will rise. If we focus on the moon and zoom in, we'll be able to see the eclipse, the lunar eclipse, if, particularly if it is an ample, there is dark eclipse and light eclipse. The dark one is called the ambral eclipse, and the light one, when the light shadow of the Earth actually casts on the surface of the moon, the full moon, that's called the ampral eclipse. This is what took place yesterday. Sometimes it's partially, but this is not partial. So, okay, let's now move on and try to see the ampral eclipse. Try to see any change on the moon. Maybe the atmosphere effect is affecting us, so let's remove the atmosphere. Fortunately, we can do a lot in these programs. Let's move up, move on, time, until we start to see the shadow. Yes, here. We can see the shadow here. Now, try to see with me. Here is a very light shadow of the moon. Here. This is not visible to the naked eye, actually. This is why we don't mention such events for the public, because it's not visible. But when it is the ampral eclipse, we usually do. We mention and we organize stargazing parties in the observatory, the SAST observatory, the Sharjah Academy observatory. And I would like to thank you. This is the end of tonight's virtual planetarium show. I will now start discussing with the audience if there is any questions. So let's start our question and answer session. Thank you.
Yes, unfortunately, yesterday it was not good for
Yeah,
the lunar penumbra. There was a lot of humidity and also some cloud around the moon. We didn't
not the
take any.
best.
Yes,
Not the
not the
best.
best.
No.
I tried this. Yes.
Yeah, thank you very much. I saw some pictures taken by you. Yeah, but yeah, it was too close to the horizon, and also the event is not that bright or the shadow is not dark enough to see it.
Yes, not dark. There is Majdi Isam, I think.
Is there any hands, raised hands?
Yes,
Maj-
Majdi Isam. Yes,
uh,
Majdi?
please, Majdi.
Yes, I have two questions. Why there is rocks near Mars and Jupiter?
Hmm, good question. Okay, let's answer the first question. The rocks. Do you know the other name of these rocks? The astronomical name?
Uh,
They are rocks. That's
Asteroid belt?
yes, the asteroids belt. Exactly. Do you know how many are there? Hundreds, thousands, millions, billions, or what do you think?
I think
According to the latest estimation.
millions.
Millions, yes, that's good. As Majid, yes, exactly. Yeah, Mr. Muhammad maybe would like to answer your question.
Yes. Yes, Majdi. The scientists, they said there is two possibility. One possibility is that this object, asteroid belt around between Mars and Jupiter, it was a huge, a very big uh, planet in the beginning of the formation of the solar system. And in that time, there was a lot of the, shock between the planets. And maybe one of this huge event, one object make a very big shock to this object, and it was transformed to asteroid like this small object, what we can name now the asteroid belt. And it stay in this area because the attraction of Jupiter and Mars, it was between these two planets here. This one theory. Another one said it comes from the beginning of the the solar system, and what we name the first nebula from which the solar system was formed. There was a huge, big nebula of dust and and gas, and this is the remnant of the that nebula, that primordial, what we name primordial nebula from 4.5 billion years ago. This is the remnant of that object. And we still now we have a lot of objects between this area. And sometime where the scientists say, for example, that Mars he can take from he take from this area two object, what we name now the moon of Mars. We have very an irregular shape. Maybe they came from this area. And also we have another Kuiper belt. This is after Neptune orbit. It's also the remnant of the original nebula from which the solar system was formed.
So these
Okay.
are
That's
theories,
right.
Majid. Theories, we have to study them more, study.
Yes.
And once we catch one of the objects coming from the outer space, like asteroids and meteorites, uh, once you study them, so we understand better and better the origin of the solar system, the origin of the Earth, the origin of the Sun, and those belts as well, where they are coming from, the composition of those, how much metal is there, how much rock it is. So that gives many answers actually to understand the origin of those asteroids. So yes, the second question.
And the second question, how Saturn gets the ice and its
The rings.
The
Yeah.
rings, yes.
Wow. Good question. So what do you think? Why don't we go there, Majid? Would like to go there to see the rings?
I wish.
Yes. Okay. So let's go now to Saturn first. Okay. Fly to Saturn. Let's fly now. We are flying to Saturn. Wow. We are getting closer to Saturn. This is Saturn, the planet that all students like it and would like to see. Look how it casts shadow on the planet, casts shadow on the rings, and also the rings cast shadow on the planet itself. And at this moment, I would like to take you through a special journey, you and all the audience, to see the rings in detail. Before we answer, and maybe we will answer during the journey. We are getting closer through the rings. We have to be careful, Majid, and everyone. We are in the rings. But as we go closer and closer, we will see something special there. And you have to be very careful. Why? We start to see billions of small rocks. Wow. This is your favorite planet, the rings of your favorite planet, Saturn. These are the rings. Yes, would like to answer, Mr. Muhammad?
Yes, there is no, several theory about this, but there is two very famous. Around Saturn there is more than 60 or now 80 moons turning around Saturn. One of this theory, they say it was a large moon that spiraled around this planet, and it was, get a very big shock from another planet, and it was, defragmented like this as a very huge, very small. This maybe one. You know, the biggest rock around it's take about 50 kilometers, not more. And it became like this huge rings around Saturn because, the attraction of Saturn. The other one said that this rings came from the outer space, from, the origin, as I tell you, from the origin of the nebula also, and coming attracted by Saturn and the other planets like Jupiter from the outer space. Not from the outer space, from from the edge of the solar system. There is a very huge Oort cloud. There was where we can find a lot of icy rocks. The scientists, they think the planets, the huge planets like Jupiter and Saturn, they attract from that area to this area, and it is still turning around Saturn.
So these are small
Yes, this is the most
icy objects dust and gas. That what actually you see when you look at Saturn through the telescope. And there are different theories about that. But more important, when we study how those actually took place there on Saturn, we have to put in account that not only Saturn does have such rings, even Jupiter, it has very thin rings, Uranus and Neptune. So the four large or huge planets, they do have rings, but they are not the same. The most dense one is the Saturns, as you see. Very beautiful. Yeah. Okay. Another question.
Yeah, when you was on Teams on this week on it was which day? Thursday. Yeah. It
Okay, so you are one of those who actually
yeah.
attended the class, the astronomy class. Great, Majid. Thank you for coming.
I w-
Yes.
I was in my daddy's account.
Wow, great. Yes, good, please. Our extend our greetings to your all family and parents and their great support to be one of those who are really interested in astronomy and space. So just be proud about your parents, yes, and
Yes,
teachers.
amazing. And there's a grade four also. He asked a very important question.
Yeah, thank you. You have another question, please?
Yeah. That meeting you will do it every Thursday.
No, actually, that is by request, by the school's request, when the schools request us to be with them to educate their students like you, for those who are really interested in astronomy and space. So we will not be very far, we will be very close to you, and we will do such sessions. So if you request your teachers to do more, we will be close. However, if not, you can be with us every Friday at 8 o'clock in Arabic and Saturday this time at 8 o'clock again from 8 to 9 in English. Thank you, Majid. Thank you, everyone, all audience here. And let's see you again, maybe, hopefully, as planned next week by Zoom. Thank you